guys, this is Miss Pruitt, and I want to make a video for you guys over limits, and this is for my AP Calculus class. So let's go ahead and get started. There are different ways that we can describe a limit. One way is verbally, another way is graphically, and lastly, analytically. So verbally says, if f of x becomes arbitrarily close to a single number L as x approaches C from either side, then the limit of f of x as x approaches C is L. Well, what does that mean? Well, let's take a look at this graphically. Let's say that L is our limit, is what we are approaching, or getting closer and closer to, as we are approaching this C value from the left and from the right. So I want to know, as we are approaching this C value, what L value do I get as we approach from the left and the right? Analytically, this is the way that we write this is the setup for a limit. This is what you've seen in class. There's also numerically. So we can set up a table. Let's say that we want to know what is the limit of a particular function as x approaches -7. Well, taking some points that are really, really close to -7 on the left, like -7.01 or -7.001, we see what our values are. We even have a value at -7. We also take points from the right-hand side of -7, like -6.999 and -6.99, and we can continue on getting further and further away. These are the values that we get. As we are approaching the -7 that we're interested in, we see that we approach 2.599. That will be our limit for -7 in this case. But let's look at Q of x, or maybe that's G of x because of the border. It follows in the next table that as we are getting closer and closer to 3, coming from the left, and closer to x equals 3 from the right, we are surrounded by a number. We're surrounding a number that appears to be extremely close to some form of 9.99. So even though we don't have an exact answer at x equals 3, there may be a hole in the graph, there still may exist a limit. All right, so let's do a couple of examples to see what we're talking about here. So number 1 says, use the graph below to find the limit if it exists. Let's jump down here to the function or the equation. The limit as x approaches -3 of 2x squared plus 7x plus 3 divided by x plus 3. So of course we can solve it algebraically or analytically by plugging it in. But let's look at the graph. So we would agree then that this line here is my graph. Something's going on here. There's a big hole in my graph. But this is my graph. And it's asked me to use the graph to solve it. Well, I can tell coming from the left and coming from the right, there's a pattern that is going on here. Even though I have a hole at my graph, at this value, x equals -3, there is an expected value. There's a hole there, but there is an expected value. It is an expected height of my graph, and that's what a limit is. A limit simply is my expected value. Or you can even say expected height of the graph. All right, so what is the expected height of the graph at x equals -3? That expected height is -5. So just from looking at the graph, I can tell you that the answer to this is -5. Last example, number 2. Use the graph below to find the following limits. So I have two numbers on my graph, A and B. And I want to know what is the limit / expected value / the height of my graph at A. Well, I look at the behavior from the left, I look at the behavior from the right, and it looks like they both are approaching the same value, the same height. I have an expected height of my graph that is 1. So I would say that the limit as x approaches A of this function h of x equals 1, because 1 is the expected value and the expected height of A at that point, even though there's a hole in my graph. So let's do B. What would be the limit as x approaches B of h of x? Well, I find B, and I go up to the graph, and I look from the left, and I look from the right. It looks like there is a value there, not just an expected value. And that value is 5. So that is my answer. The limit as x approaches B, as x is getting closer and closer to B from either side of h of x, which is the name of this function, the answer is 5. And that's it.